All right. So, all right, I gotta chill here because my battery is lower. All right. Problem number one, it just says f of x is equal to 2x squared minus x. And I just saw my error. So friends, if you see it doing f prime of x, this means this prime means I'm going to do a derivative. So the derivative of this is going to be 4x minus 1. Okay, that's first step. That's A. Easy enough? So if you didn't remember the derivative, you bring down the exponent, you reduce the exponent by 1. This has x to the first, and then this technically became x to the 0, which then that just comes out to this as your derivative. Okay? And then find the instantaneous rate of change at x equals -1. So that means I'm going to plug in for x on the derivative. So that's going to give me 4. This was an x right here, minus 1, which is this. And if I do that math, I wind up with -5. So that basically means that is the slope at -1 here on the original. And then find the point on the graph at, oh, okay. Then letter C, if I want to go back to my original, at x equals -1, I'm going to take -1 and plug it back into my original. So I'm going to take this, I'm going to place it in for here and here. Okay? So that means that I'm going to have 2. That's where x was, and that's where x was. Now I'm going to plug the -1 in for both of those. So that's going to just give me 2 plus 1, which is 3. So basically what this whole thing tells me is on my graph, this is what it does. I gotta jump on with this. So this is our slope. This is the slope. This yields me the point -1, 3. So if I were to do my point slope equation, and plug in those values, I'm going to get y minus 3 equals -5 x plus 1. All right. This is what it means. I'm going to graph on Desmos. So I'm going to graph none of this. I'm going to graph so this is my original function, and then I'm also going to graph I'm going to graph get rid of that. No, I don't want to save that. I'm going to graph y minus 3 equals these -5 x plus 1. Okay, so this is the point they're basically referring to. This is the point of tangency on that line. So if I kind of zoom in on that, that blue line is the line tangent exactly at that point. The linear equation to that line is, I left it in point slope, which because Desmos does, which is kind of cool. So take care of that. Hang on, a couple people came in. Diego and Ashley. Okay, that's the whole meat and potatoes of this whole thing. You have this blue line that's tangent exactly there. That tangent line, remember, tangent line touches a line once. So that is the point of tangency. That's where it kisses the line once when you move on. Okay? So that's the first part of number one. Does that seem okay? I hope. So the steps in doing this, steps to find tangent equation. Oh my gosh, come on. My computer's working too hard. Is first thing, take derivative. Second, plug in x value given to the derivative, and that'll find the slope. Third step, plug in x value given to original to get point. So plug in number 3 point and number 2 slope. Oh my gosh, I don't know why this is getting all goofy on me. All right. Then we move to problem number 2. Number 2 says what estimate is rate of change positive, where's it negative, so on and so forth. Okay, so we have this graph that kind of does this. Okay, and they don't really give you any values. They just say like up here is this would technically be the point 0 comma A. This should be the point 0 comma C. This would be the point 0 comma E. And oh, never mind. They should, only the first one should have been 0. So this is an X value. This is a X value. Sorry about that. That's a good point. You caught me in a lie. And so for problem number 2, it says what intervals is it positive? Okay, so it's basically from negative infinity up till A, and then from C to E. Those are where our slopes would be positive. Okay, so over what intervals A through D is the rate of change positive? So over here, that's just saying that these would all have positive slopes and these would all have positive slopes between those regions. Okay, and then letter B, we want to know where everything would be negative. So it's negative from A to C, and then from E to infinity. So right here, all of our lines, if we took the instantaneous tangent line, we would have negative slopes between that, and that's basically taking place. At the points themselves, that's where it's at 0, So at letter C, where is everything 0? That's meaning the tangent line. So at point A, C, and E, that would have a tangent line that has a 0 slope. So it's a horizontal line. And that's really all I have to do. So this would be a 0, this would be a 0, this would be a 0 as far as the slope. So derivative refers to the slope of an original problem. That's the equation you use in order to plug in an x value to find the exact value of the slope. So if you plug into an x value into the derivative, that finds you the slope at exactly that point of the line that's tangent, and the tangent line touches the line once, or the graph once. Number 3 says, at what points A through E is the rate of change, f of x, change from positive to negative? So for problem number 3, where does it go from negative to positive? So all you do is you're like, okay, negative to positive. So at point C is the only place where it goes, where it was a negative slope then to a positive slope. So it's this little region right here. And then at what points A through E are the rate of change negative to positive? So that's the answer to A. Answer to B, where does it go from positive to negative? So positive, negative is at point A and also point E. Okay, so it goes from positive to negative, positive to negative. Cool. So those were a little bit different types of thought process problems, but I think I might have backfilled where my errors were in my life. All right, so going on to problem number 4. If I have y equals 4, the derivative, so y prime would be 0. Remember, the prime is going to replace the derivative now, or d over dx. Number 5, if I had g at x equals 10x to the 9th minus 5x to the 5th plus 7x to the 3rd plus 5x minus 6. If I wanted to find g prime at x, that's the derivative. So I'm going to get 90x to the 8th minus 25x to the 4th plus 21x squared plus 5. Derivative of negative 6 is just 0. And number 6, my number 6, the 6 is blurred out, but I think we can figure out where this goes. All right, you have to be careful on these. So f prime at x is going to be negative 5x. Subtract 1 from negative 5, so I get to negative 6. And then I get negative 8x. Subtract 1 from negative 8 till I get to negative 9. And then the derivative of minus 3x is just minus 3. Derivative of 10 is 0. So that's all we do there. And then, are you ready for me to go to another slide? I hope. All right, now number 7, C is, we have f at x, 3 over x to the 4th, plus 2 over x to the 5th, plus 5 times the 3rd root of x. Okay, before I do anything, I'm going to move things up. So I'm going to change places. So that becomes to the negative 4 power. This goes to the negative 5 power, so I no longer have denominators. And then the 3rd root of x is going to be x to the 1/3 power. Now I can go ahead and take the derivative. So f prime at x, that's going to give me negative 12x. Subtract 1 from negative 4, I get to negative 5. Minus 10x. Subtract 1 from negative 5, it gets to negative 6. plus 5/3 x, which is 1/3 minus 1, which is 1/3 minus 3/3. So that's to the negative 2/3 power. And this is your derivative. Okay, doke, artichoke. All right, today's Tuesday, right? So will you finish worksheet 4.3? And mainly I'm looking 4.3. I'm looking for problems 8 through 11 to be done. And I can help you with any of those. Problem number 8 is similar to problem number 1. So is number 9. And then 10, see if you can figure it out. If you get to 10, you have a question about it, let me know, and I'm happy to help you. And then number 11 is done the same way. Just make sure you turn the square root of x into x to the 1/2 power. Deal?